Hi guys, welcome back to my channel. So in this tutorial we are going to look at this integral of tan inverse of x divided by 1 plus 1 over x squared dx. So we are going to use our integration by parts mostly to solve this integral. So if you haven't subscribed to my channel yet, this is a small channel. Make sure you support my channel by hitting the subscribe button. So let's solve this integral. So first we can start off by rearranging this integral. So the integral of tan inverse of x all divided by, this can also be written as that's the denominator, that is 1 plus x squared all over x squared dx. So we can flip the denominator, so that becomes tan inverse of x times x squared here, all divided by 1 plus x squared dx. So with this one we can now use integration by parts. So let's do the integration by parts in a different color. So first I am going to start off by writing d and I, that is the shortcut. So I am going to differentiate the tan inverse of x because that is easily differentiable, and I'm going to integrate x squared all over 1 plus x squared. This plus, this is minus. If I differentiate tan inverse of x, that is 1 over 1 plus x squared. What about integrating x squared divided by 1 plus x squared? I can do that here real quick. If I'm integrating x squared over 1 plus x squared dx, I can do some manipulation by adding 1 and subtracting 1 in the numerator. The denominator stays the same. So this can also be written as the integral of 1 plus x squared over 1 plus x squared dx minus the integral of 1 all over 1 plus x squared dx. This simplifies to 1, so the integral of 1 dx minus the integral. This is the tan inverse of x. And integral of 1 is x minus tan inverse of x. So if we integrate this, we are going to end up with x minus tan inverse of x. So I can write that here, x minus tan inverse of x. So I can erase this now. So we can now do the trick, that is by multiplying the diagonal terms. So if you multiply terms diagonally, you are done with the integration, but if you multiply terms horizontally, we have to take the integral. So our integral now becomes, multiplying terms horizontally is going to be x minus tan inverse of x. All this is multiplied by tan inverse of x minus, that is this integral, the integral of 1 all over 1 plus x squared multiplied by x minus tan inverse of x. All this dx. So here we are done with the integral. This is x tan inverse of x minus tan inverse of x all squared, like this, minus the integral of x all over 1 plus x squared dx, and then minus minus, that becomes plus the integral of tan inverse of x all over 1 plus x squared dx. So we are done with this. Can just write it again, tan inverse of x minus the tan inverse of x all squared minus this integral can multiply 2 to the numerator and divide by 2 dx plus the integral of tan inverse of x all over 1 plus x squared dx. Let me tackle this one for now. So this one, the differential of the denominator is the numerator. So this is just the natural logarithm of the denominator. The denominator is positive, so you don't need to put it in absolute value, plus the integral of this one, integral of tan inverse of x all over 1 plus x squared dx. With this integral, we are going to use a u-sub. We can let u to be equal to the tan inverse of x. So that implies that du is equals to 1 all over 1 plus x squared. So du dx is that. So in that case, du is going to be 1 all over 1 plus x squared dx. So in place of 1 over 1 plus x squared dx, we can replace that with du. So this integral tan inverse of x, 1 over 1 plus x squared dx. This is the integral of tan inverse of x is u multiplied by 1 over 1 plus x squared dx is du. So we are just integrating u in the u world, which is 1 over 2 u squared. And then we plug in u was tan inverse of x. So in that case, this integral reduces to 1/2 tan inverse of x all squared. So we have the value of this integral. We have integrated this, which we got this, so we can just put everything together. So in the end, we are going to have, that is from here, x tan inverse of x minus tan inverse of x all squared minus this integral, which we got to be 1/2 natural logarithm minus 1/2 natural logarithm of x squared plus 1 plus this integral. And this integral, we got that to be 1/2 tan inverse of x all squared. So plus 1/2 tan inverse of x all this one squared. So we can do some simplification. This and this can be simplified. So in the end, we have x tan inverse of x. This and this combine to negative 1/2 tan inverse of x all squared minus 1/2 natural logarithm of x squared plus 1. So this is how we can simplify it. So in the end, our integral, which is the integral of tan inverse of x all over 1 plus 1 over x squared dx. This can be simplified to x tan inverse of x minus 1/2 tan inverse of x all squared minus 1/2 natural logarithm of x squared plus 1 plus the constant of integration. So this is the value of this integral. So that's it. That's how to solve it. If you find this video helpful, make sure to give me a thumbs up, subscribe to my channel for more content like this. Thank you so much for watching this video, and I will see you in the next one. Bye bye.